this video, I want to go over a technique you can use to double check your work and to see if the answer you got solving an integral is correct. For example, if we want to solve this integral, how do we know if we got the correct answer? For example, let's do this integral. So solving this, of course, you would do the integral of each of the components. So that would be the integral of x squared plus the integral of x plus the integral of 2. And of course, there would be the dx's. So then you just solve this. So x to the 3 over 3 plus x squared over 2 plus 2x, and then of course plus c. So how do you know this is the correct answer though? What's the technique you can use to double check your answer and to make sure this is the correct answer? Well, we know whenever we're given bounds, when we have a definite integral, for example, let's say we had the same integral, but it was a definite integral, so we had bounds of 0 to 1, we know we can double check our answer by essentially plugging this into the calculator, and then we would get a value, and the value would actually be 17 over 6. So we get this value, and then now we plug in those bounds to this integral that we originally solved. So 1 to 0, then you would just plug, you would solve this integral. And if you also got the same answer, if you also got 17 over 6, then you know this was the correct way to solve that integral. So again, just simply put, if you're ever given an integral and it's an indefinite integral, and you don't know if you solve it and you don't know if that's the correct answer, a simple technique you can use, and this worked for me every single time while taking Calc 2, a simple technique, you essentially just make up bounds. You just make up any random bound. So let's just make up whatever's convenient, so 0 to 1. Then you solve this using a calculator and you get an answer. And now you double check the answer that you got previously with these new made up bounds. You see if that equals, if you plugging in these bounds and getting an answer, if this equals the answer that the calculator gave you, then you know this was the correct answer while solving this integral.